Yes, good evening, sir. Krishna Kumar, sir. Good evening. I am Dr. Malarvidi from Wiltech.
Good evening, ma'am.
Nivetika, ma'am, you available?
Ma'am. Yes, ma'am. I'm here.
Okay. Let's start the session.
Okay, ma'am. Shall I start, ma'am?
1 second. Rajesh, sir. Recording start பண்ணிருக்காங்களா ராஜேஷ் சார்?
Yes, ma'am. Recording started.
Yes, very good evening to Anandal present here. I welcome you all for the 4th day of our online Atal FDP titled Enhancing Cyber Threat Detection through Incorporating Digital Technologies. So today also we have 2 sessions from 6 to 7:30 one session, 7:30 to 9 second session is there. So first session will be handled by Mr. Krishna Kumar. He is from Microsoft. Second session will be handled by Ms. Priya Maturu. So now I'll give my credits to Nivetika ma'am to introduce our today's resource person, Mr. Krishna Kumar. Yes, over to Nivetika ma'am.
Yes, ma'am. Thank you. I, Mrs. K. Nivetika, Assistant Professor of Failtech, much glad in welcoming the coordinators, organizers, speakers of today and all the participants for the day 4 and session 7 of online 6 days faculty development program on enhancing cyber threat detection through incorporating digital technologies, sponsored by All India Council for Technical Education, AICT, New Delhi, organized by the Department of Computer Science Engineering, Weltech Rangarajan, Dr. Shakuntala R&D Institute of Science and Technology. I take pleasure in introducing Krishna Kumar, fondly called as KK. KK heads the Commerce and AI Engineering Unit of Microsoft as Principal Engineering Manager. Prior to this, KK was heading Finance Technologies as JP Morgan as Executive Director. KK has been working on SAP and ERP technologies for more than 2.5 decades and has played varied global and regional leadership roles in Honeywell, HP, and SAP Labs as well. He brings in a lot of passion and diverse experience in architecting and delivering enterprise projects in the cloud and on-premise delivery models. He has led the digital transformation journeys of many customer projects and has contributed to the success stories of building innovative customer solutions in the areas of big data, SAP HANA, cloud, hybrids, blockchain, IoT, and S4HANA. He takes pride in his contributions to some of the most complex architectures and landscapes of enterprise giants like Dalmia, Sony, Tata Telecom, Ultratech, Samsung, and CAG. In the year 2019, KK was awarded CIO 100 Top Disruptive Leader of the Year by IDG. An active member in the CIO forums and also a vivid reader, Krish holds an engineering degree in computer science and masters in software systems from BITS Pilani. He is currently pursuing his PhD at IIIM. Please join me in welcoming KK. Welcome, sir. The forum is yours now.
Thank you so much, Nivedita. I hope I'm audible. Let me share my deck and start off. In case there is any difficulty in the audio or video, just let me know. I hope you should be able to see my deck by now. Just give me a thumbs up or a quick signal that you're able to see the deck.
Yes, sir.
Okay, and I understand this is an FDP program. This is basically giving some pointers for the professors to enable themselves with the latest topics, what is happening in the industry, what is interesting for the students to pursue as final year projects or research projects. So in this regard, I'm going to do this session. From a level point of view, it is more of a beginner fundamental session. It is not going to be advanced. So normally I look at these programs and presentations as pointers. Basically, it's not like you can do a session of 1 hour and learn coding and scripting and all of that. if suppose we are doing a session, that session should give you some search terms and things that are pointers for you to go and find out more and research on that topic, then that would be a fruitful session. So in this regard, I have picked up the security topic today, the most interesting topic of the industry, and a little focus on threat intelligence, what the big companies do for threat intelligence using AI. That will be the theme of this entire presentation. Let's start off on a lighter note. So welcome to the world of AI and security threats. So today, everything and anything, people say we have to AI enable it. Most of the organizations have recruitment in large numbers for AI managers, AI engineers, and so on. And there is no agenda of what is to be done using AI. It is like, okay, let's get the people, let's get the systems and do something on AI. That is how things are working today. See the first picture where somebody says, let's turn on artificial intelligence, see if it has anything intelligent to tell us. So that's how the industry is adopting AI in every part of the world. And the funny thing about the education industry is the students are preparing their papers using AI, and the professors and the faculty members are evaluating these papers also in AI. So this is the funny situation that we are in. You're all muted. I'm not sure whether you're laughing at it or not. If you can unmute yourself or if you can turn on your videos, that would be great. Let's start off with this on a very lighter note. And these are two quotations that caught my eye. So everybody is saying that will AI take our jobs? Will the whole world be ruled by AI and so on? Now, if suppose somebody is going to get into a car and there is no driver in that car and you are ready to try that automated car, if you have that much of trust that it will not crash you, it will not create an accident for you, your life will not be threatened. If you trust AI to drive a car, then obviously people will trust anything and everything for AI to do the job. That is an interesting quote, and we have reached that stage. In places like Dubai, in US, you see taxis where there is no driver at all. And people worry that computers will get too smart and take over the world, but the real problem is they are too stupid and they have already taken over the world. So I I get this funny incident here in places like Bangalore and Chennai. For example, there is a big board on one of the big roads, Khichdi Festival by Swiggy or Zomato, which means khichdi is something like upma in our South India. So it's like on that week, khichdi and upma is offered by Swiggy and Zomato at the lowest price, maybe 30 rupees or 40 rupees for a packet. And you won't believe that it is promoted so much. It is on the app. It is prompting people to use it. There are patterns of who orders when and so on. It's like the whole city is eating upma or khichdi on that day. So computers have gone to an extent that there is a data of customer buying pattern. Based on that pattern, there are some numerous algorithms that work on it, and then it suggests some of the things, and mankind is following all of this via different apps. Each person thinks that he or she is doing it only for himself or herself, but actually the whole city is following it. So we are already taken over on what we wear, what we eat, where do we go. All of this is determined by the AI world today. So this is the state in which we are there. The moment we talk about AI, there are a number of topics that are always being brought to the forefront. Predictive analytics, deep learning, machine learning, speech to text, text to speech, robotics, vision, image recognition, all of this somewhere get into the crux of it. All these topics emerged in different times, but now all of them are converging into one big bucket called artificial intelligence. There are many people who are using these three terminologies mixed: artificial intelligence, machine learning, and deep learning. But actually, they have distinct meanings. if you take artificial intelligence, it is basically a set of rules. These rules are built by humans, and you are giving some kind of intelligence to mimic a behavior again and again. For example, if there are chess coins, you want the computer to play chess based on the different moves. You are giving the rules upfront and say, now you play with humans like this. So here is a rule based action, that is artificial intelligence. But on the other hand, it's not only rules. Suppose you give them data. If this data comes up, then the model has to behave like this. Then the moment we do that, which learns from data, which means the more and more of data that we give, then that is called machine learning. But on the other hand, you are going to give a set of rules, you are going to give data, and then you are going to make it learn in a very advanced fashion with several parameters, and it is able to take decisions on its own, and it is trying to solve real world problems. For example, the autonomous self-driving cars, or for example, you ask queries to devices like Alexa and say, now I tell something, you understand that, based on the rules, find out some answers, fine tune that answers and give it back like an Alexa or a smartphone or a hands-free speaker. So that goes into deep learning. So it is about the level of intelligence. And if you really look at it, we are in the third stage of deep learning models, where we are not only having rules and data, but there are decisions that are made based on several parameters. Recently, there was a very interesting article which I saw in LinkedIn. There is an autonomous car driving in US. So the car is programmed in such a way that, okay, when there is a red signal, it should stop. When there is a green signal, it should put the indicator and go to the right, and all of that is there. But on that particular day, there was a policeman who stopped the car. But the car didn't stop because the car did not have a rule or an identification of a policeman. So if there is a policeman who says stop and pull the car to the side, the car doesn't recognize that human as a policeman. It just keeps going, or it keeps moving away from the human because it doesn't want to collide. But it is not pulling back the car to the right side and stopping. This was a very interesting use case, that you can build intelligence about roads, cars, signals, and so on. But at the end of it, the policeman is not being recognized by the autonomous car. At this point, before I go ahead, am I clearly audible to you? Are you all following? I just want to be sure, because it seems to be like a monologue. Is everything okay? Anybody unmuting? Shall I move on? So far, so good. Okay, there is nil response. I do not know. Let me continue, or somebody give me an yes or a no later after unmuting. Pallavi ma'am, is everything okay? Am I audible? Is the slides clear? Are you able to follow? Or Amuda madam, can you please confirm? Amuda ma'am, you are unmuted. Okay, I will take that as an yes.
Sir, it is not visible, sir.
Slides are visible now.
Yes, sir. Slides are visible, sir.
Okay, let's proceed. Fine. So now let's look at the architecture layers of AI. So if you have an application, what will that application look like? For example, you will have different types of users on the top. You will have business users. You will have an AI engineer. There will be data scientists who will be providing data for the architecture. There will be testers who will be testing these applications. So they are all going to have several use cases, frameworks, and all of that. How are they going to interact? Basically, vision, speech, text, some kind of data, and so on. So we have the AI models which are interfaced via APIs, and then these APIs collect the data. So now you are getting a repository of data. You prune that data. You make the preparation for the data. You define a model. You make the data better and better. You classify that data. You store that in the model. You build features of AI on that. So that's the middle layer where you build the intelligence part. Now at the end of it, if you have to put it into action, you take all this data into a public cloud and then start training the clusters. Here is where the infrastructure and the cloud management part comes into play. So if you do all of this, which means there is an application, there is a way of capturing vision, speech, text, there is a lot of data in the model, you strain the data, and ultimately you are able to make something meaningful out of it. That is an AI application. Another diagram for easy understanding. So if you really look at it, if you are giving voice should be converted into text, or if you are giving text should be converted into voice. Suppose you are querying something, there should be search engines for it. If you are able to connect to social networks, you need the connection APIs, you need keywords, you need prompts, you are able to classify the words, you are able to tokenize for security purpose, you are able to get opinions from the emojis and the expressions. You are able to have some kind of computation based on this. So these are all called semantic analysis or linguistic extractions, data acquisition, data seeding. These are all topics which you can further query and find out details. Now, if you will have an artificial intelligence architecture like this, there is a lot of security threat at each level. For example, if the voice is actually spoken by a human or is it not a human? If the query is returning wrong results, what do you do? Or if there is a keyword or a voice message, is it ethically correct or is it using an abusive language? The kind of pictures, the kind of videos, in all of this, there are limitations and constraints to be made for the AI application. So we need to beat the threats that are hitting this at all levels. So that brings us to the main story of security threats. So what do you mean by threat modeling? Threat modeling means you are going to create a hypothetical scenario, which means the scenario might happen in future. You are going to make system diagrams. You are going to do a lot of testing with data and then see how the system behaves. So threat modeling has four parts. It can be strategic threat intelligence, it can be tactical threat intelligence, can be technical threat intelligence, or operational threat intelligence. So at the end of it, what are we trying to see? Is there a risk? Is there a vulnerability? Can I do some corrective action? That is what you are trying to do using threat modeling. So a very simple thing. For example, if you are talking to Alexa and saying, hey, can you play the movie song of this movie? Now, if it is correctly searching that movie song and playing, you are actually doing a test of the system. Now, when you are trying to do that, if that is randomly playing some songs, or if it is definitely not tailored to the query that you make, then the system is behaving in a different way and we need corrective action. So this becomes very a bigger problem when you have the system starts hallucinating, which means you ask something, the response from the system is totally different. So threat intelligence prepares the organization to prevent, to detect, and to mitigate the threats. What is a threat? For example, if the organization's data is being stolen, that is a threat to the data. Or it could be a financial risk, or it could be some kind of reputational risk. All these are assets. So an organization is just not a building. In that building, if you want to bring down an organization, you spread bad news about that organization, that's a threat. You steal the confidential data, their IP, their copyrights, etc. You steal that, that's a threat. You get the data about their salary, finance, etc., and then publish it to a larger audience, there is a financial risk. Suppose you write programs in which you make the memory overload and this stops all the computers because of memory overload, then you are actually stealing the asset which is memory and storage. Suppose you are having a multi-instance cloud application. Suppose you give a lot of computing and all the instances are locked. That is the computer is running in full swing, which means you are misusing the computing resources. So a threat can be done in any way by an attacker. So you see what are all the data sets. What is the pattern when it happens? If somebody is breaking into your network, what is the pattern in which somebody is breaking in? What are the potential risks in this? And how organizations detect it and respond to it? This process is called threat modeling. So the right side circle 1, 2, 3, 4, 5, 6 gives you a step-by-step process of how to do threat modeling. So you identify the assets, you look at the architecture, you break down the application, you look at what are the different types of threats, you rate them, you classify them, and then you prepare mitigation action. So as I said, there are 4 types: strategic, tactical, technical, operational. So the definitions are there on the screen. You can have a look at it later. From an example point of view, as I already said, you can attack and take the documents, white papers, data. This could be an example. For example, if there is a medical company, they are using a lot of formula to invent a drug. If some threat happens by somebody logging into their network and accessing all the formulae of the medicines, and they take out all the white papers, formula, policy document, it's a very big threat for them. So for them, it is an attack on the policy documents. Now, what is the latest type of threat? Every organization is having a chatbot, or every organization is having chat GPT or Copilot. So all you need to do is get a network access. Just like an employee, you have to get into the network, and through that, after getting into the network, you use the Copilot or chat GPT to query. So what is the salary of the employees? What is the confidential data about the financials? So the network thinks that you are a valid employee and you are querying the Copilot, but an invalid entry coming into the network, and then you leverage all existing AI model by which you query the data and get access to the whole company's data. The third one is attack on business process. So let's say recently what happened in Myntra, Meesho, all these companies, what happened was there were hundreds and thousands of orders that were made, and all of these orders were fake orders with fake names, fake address, and all the orders were returned, and there was a big fraud that happened on the returned items and so on. So this was close to about $1 million. So this recently came back 1 week back. So what you're doing, there is a delivery process. You order in an app, it goes to a vendor, there is a picking and packing, then there is a delivery agent who comes and delivers, and then if there is a return, there is a pickup, and then there is a refund back. This is the business process. Somebody has tapped the business process and attacked on it. So now without a valid user, without a valid e-commerce, there is a process attack. This is one type of attack. Then the other type of attack is, for example, if you want to, if there is a competition between two companies and both of them are doing a Diwali sale, what you do is you create so many queries, so many orders on and attack all their resources and make all their computers busy. So now what happens, anybody who tries to log in, they get a 404 error. They are not able to see the system, or the system becomes slower. That is an attack on the system resources. Then phishing attacks. So this is very common. You will have got some junk mail. You click on that. They take access of the computer or the mobile device, and then every possible detail, your OTPs, your confidential documents, your chats, everything is being fished out of that. Then the other thing is fake videos. So right now you can see a lot of fake videos. The most popular personalities, for example, if you take Tamil Nadu, every day you can see a fake video about the financial expert PR Sundar, as if he is giving gyan about which share to buy or which share to sell. Somebody is creating fake videos. There are fake videos of Narendra Modi. There are fake images. Somebody is getting arrested or somebody is getting hit. Those kind of activities have never happened, but AI generates these images and videos and creates a lot of reputational risk and damage to the individuals or the organization. So these are all some of the examples of threats faced today. So what does the threat intelligence cycle mean? So you have technical resource, you have human resource, you have internal sources. Now the objective is you have to see what are all your assets. Even humans are your assets. Now you have to find out what are all the ways you have to attack. Then find out what are all the risks that are there. And then if there is such an activity that happened, how do you mitigate that risk? For example, let's say all our bank accounts have been deducted with 1,000 rupees. Now all of us go back to the bank and complain about this fraud. So the bank looks at a root cause analysis from where this program triggered 1,000 rupees debit on so many accounts. Then they try to see, okay, now how do we return back and see how many accounts are affected, which are all the geographies that are affected, how do we give back. So this is the incident response and the subsequent action. So it starts with an incident. It starts with the security operations team finding that something has happened. Then they look at what are all the vulnerabilities or the things that has got affected. You calculate what is the risk that has happened. You evaluate the frauds in terms of finance or non-finance numbers. You intimate the security leadership, and then you plan some kind of an action towards it. This is the threat intelligence life cycle. So now I'm going to talk about three terminologies which are abbreviated. The first terminology is called STRIDE: spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. The expansion of STRIDE is actually given here. So here I am giving you a small link. You can have a look at it. It's a EC Council link which is there. It clearly talks about these aspects of threat modeling. What are the different threat modeling and what is, so there are, what we are going to see is STRIDE, PASTA, DREAD, Octave, VAST and Trike. These are all the different modeling techniques. So right now we are talking about the first hexagon, which is STRIDE. So spoofing, tampering, repudiation, information disclosure. Let's see what is that. So this site link I have provided here. You can read about it in length, but I'm going to give you just pointers here. Spoofing means as if some person is there, there is somebody else who is impersonating, which means in my bank account, if as if I am giving a user ID and password, somebody else is doing and taking my mobile number and generating an OTP. So the system thinks that this is person X, but actually somebody else is operating. This is spoofing. Tampering is you somehow hack into a system and change the data. For example, you are actually having 10,000 rupees in your account. So you are able to tamper the account's data and make it as 1 lakh rupees. So you are modifying the data. You are breaching the data integrity. You are getting into the memory and storage disk. Repudiation is basically claiming not to be responsible for an action. So there is a damage, but this is not created by me. Information disclosure is somebody who is not supposed to see that information. Let's say all the salaries of all the employees are downloaded into an Excel sheet, and that Excel sheet is available to all the employees. Now here is the confidentiality breach. So you should not be knowing the salaries of others. So you should not be having that kind of a situation. So information disclosure. Denial of service. When you want to start an application, you want to order something, and now it says shopping cart not available. So which means you are not able to proceed to create the order. Then you are allowed to see some data, but you are actually getting higher authorization. For example, you are supposed to know your salary and your employees below salary. But if you are elevating your authorization to a higher level and you are able to see your MD's salary. So this is elevation of privilege. So this is called STRIDE methodology. Spoofing, tampering, repudiation, information. So each of this is a use case. So if finally a student is saying, I want to do a project, you can pick up one of this and say that pick up a cloud application, use a security tool and model denial of service, and that's your final year project. Or some other student can be doing elevation of privilege. So why I am explaining this topic is this topic will help you give the final year students some kind of meaningful projects. The next one is a nice thing to listen to. It's called PASTA. PASTA means process for attack simulation and threat analysis. So you are actually creating a project in which you create a plan. You look at who are all involve them, and you actually do the tools, techniques and procedures, and you integrate it into the organization security network, and then you communicate what is the outcome. So you are, if somebody would attack the organization, you actually mimic that behavior. You define a scope, you see what are all the vulnerabilities that get hit, then you model that, you simulate that, you calculate the risk and do it. So each activity is a project. For example, creating the threat itself is a project. Once that threat happens, how do you evaluate that is a project. So each line in this is a separate project. So you do the process for attack simulation and threat analysis. That is called PASTA. The third one is called DREAD, DREAD. It's a methodology. Now, for example, I am going to my organization and raising a ticket. I am saying that I am not able to log into my computer. My password doesn't work on Windows. Organization has given me a laptop. I have a password and I know the password and I am trying to log in. I am not able to log in. Since I am not able to log in, I am not able to raise a ticket also. So I pick up the phone and say I am not able to log in. Then there is a damage, which means if I don't log in, I am not able to work. Now they are trying to see what has happened. Has somebody else changed the password, or has somebody attempted many times to log in? Now they find that in yesterday night, there has been an attempt on the Windows login to find out that they see that there is an attack on the network. Then they immediately see how many affected people are there. Out of 1,000 employees, how many of them? Then they see that almost 50 employees have been affected. Now you see, if suppose this employee is not able to log in, but everything is fine. But now you look at other employee and see, has all his data been compromised? So look at what is the The incident is password not working, but what you discover out of it will be multiple fold. So you look at a damage, you try to reproduce that error, you find how the exploiting happens, you quickly find how many people are having the same problem, and you find a vulnerability to discover and mitigate that. This methodology is called DREAD methodology. So this could be like, for example, somebody hacking into a library and borrowing all the books, or somebody getting into a online ticket and getting all the tickets and trying to take a leverage of their usage of the tickets. So we saw Stride, we saw Dread, we saw Pasta. So again, quick recap of the words: spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege, damage, reproducibility, exploitability, affected users, discoverability, process for attacking, simulation, and threat analysis. You can use any of these threat models and create a project for your students. The project could be one of these model and one of the topic in that model. That itself is a very, very good way of suggesting a final year project. Let's go one step further. All these are manual. Now let's go into automation, some kind of integration and collaboration. Here the most important word here in Trike is the word CRUD. What is CRUD? In a database, I am creating records. I query the database and read the records. I read the records and update the data, and at last I delete the data. So in simple terms, let me explain. You create a shopping cart in Amazon. First time you add some objects to it and create a shopping cart. Then after some time you go and click and say what is there in the shopping cart. You read that. Then you change the quantity or you remove some of the items in the shopping cart. You are updating it. Then lastly, you are deleting some of the items from the shopping cart. So create, read, update, delete. The CRUD method should be tested at all times in any database. If create is working, is read is working, is change is working, delete is working, each of it has its own risk. So you draw a data flow diagram for it. For example, I start in this application, I enter all the details, I press the save button, data is created first time. Now for read, I go and give an order ID and say, give me details. Am I authorized to see that order? Am I seeing my order or somebody else's order? Do I have the roles and privileges? That is the read flow diagram. Update. You are allowed to see some data, but you are not allowed to update. For example, you are allowed to see the timetable of classes in a college, but you are not allowed to update it. You can only see it. You have only viewing rights. Then last is delete. In most organizations, we don't delete any data at all. We only archive the data. So somebody who's having delete permission will have the highest level of permission. So Trike is a model where you look at a requirement of how you can use the CRUD methods for each of this. For example, if I am using an e-commerce application, I automate this. Can I create 10,000 shopping carts? After creating 10,000 shopping carts, can I create a delivery mechanism? Can I integrate it with another application? Can I see some of these integrated to a social media application? So can I collaborate like this? So these are all the ways. So here it is visual, agile and simple threat model that is called VAST. So in addition to Stride, Dread and Pasta, you have Trike and VAST model also. So if all of this is concept, you will say, okay, now what can I do in the system? So here is the link for that. If somebody says, okay, I want to do a project, where can I get the systems for it? You click this, you will get a list of tools. So here the threat modeling tools are available. Now you can use these tools for each of them. For example, for a CAD professional, what is the tool? For a threat modeler, there is a tool. There is a tool called Tutamin. So maybe we click that and see what is that. So this is a tool that somebody can learn and do it. So if you really look at it, there are many tools actually. So Microsoft tool is called Microsoft Threat Modeling Tool TMT. It allows software architects to identify and mitigate the most likely. So as a first step, what you need to do is you have to go to your student and say, now you attend a basic course on TMT tool or secure CAD tool, or you do a basic course on Tutamin, or you have to pick up one of this tool and say, first you attend a training on this tool, how to do it on the tool. Second thing, what you need to do is you have to go and talk to an industry person and say how to get a problem statement. For that problem statement, you should model that into this tool and then you should execute the project. So this is the step-by-step process. So there is business, there is tools, there is a model which combines the business on the tool, and then after that, how you do the security operation on that tool. So these are the steps for it. So we saw what is a model. We saw what is a methodology. Here is the tool, which is the third step. Sir, you are telling this all at a high level, but step by step, can somebody teach me? So here is a step by step method on how to create your threat model. So every step of using a tool, putting an architecture diagram, listing down the vulnerabilities, and then finding how this could exploit a situation and what are the security controls. Step by step, right from making a diagram till implementing in the system. Here is a link which provides that. Give this to the students and they can actually use this template also for creating it for the documentation also. So if you are using Stride, then Stride itself is explained very detailed here. If you are using other models, that is also available. So this is a step-by-step model of creating a real world threat modeling scenario. So you can use this for your students. Now I'll come to the last part of the presentation. So all the applications that we are talking about, which are having security threats, are built on something called microservices architecture. This is not the on-prem server architecture. Here you will have your code and logic, which is in service A, B, C, like that. You are breaking down the entire application into multiple services. Then you build APIs on top. And from your devices, you use load balancer and CDN to access this API. And there is communication via message broker. So this is a new architecture of any cloud-based application. We will have more and more of cloud architecture only in future. So the next generation kids need to know this diagram for sure. If somebody will say, I know UI, I know code, I know DB, that's a old style architecture. If somebody needs to attend interviews in companies like Google or Microsoft, the first and foremost thing they would be asked to do is draw a microservices architecture and tell what is the benefit of it. This architecture is scalable. You can make 1 million users log into the PC and access different services. It will not break. The traditional architectures will break. This is device agnostic, which means you can run this application on a mobile or a web or a PC, whatever may be. Now, to make this easily understandable for you, let me give an example. Your house washing machine is gone repair. So let's say there is a service engineer who has to come and repair it. So the service engineer is having an application. He is having it on his iPad or mobile. So there is a service order, repairing the washing machine, visiting at this hour to this hour. This is the address, this is the customer number, this is the warranty period, everything is there in the application. So a washing machine or an AC service engineer. Now in order for him to come to your house, there is a field which gives the GPS data, which means the GPS coordinates. Where is your house? Now let's say creating the service order is application service 1 and GPS is second service of the microservice application. Let's say the GPS service is down. So if you look at this diagram, service A is up, service B is down. Now you should not say just because GPS is not working, you should not create the service order. The service order should be able to create it. GPS information is not available, maybe you will update it later. This kind of designing the systems to adapt is called failure adaptation or resilience engineering. Now the same thing, if an application has 10 services, you hack that application and you bring down all the service, then that is called chaos engineering. So this is how the new age architecture works. So if there is a security threat, it is actually doing chaos engineering. So if you are doing chaos engineering, you will pick up an application and not test it in sequence like A, B, C, D. You will test it across A, B, C, D all together. An integrated way you will test it. So we have a lot of integrated applications. You have drones, you have cloud applications, you have mobile applications, you have devices, you have wallets, you have payment services. The world is full of this complexity. So you should know to test these applications in a different way for security. So in security, you might need to know at what all layers it can be. Your application is here in level 7, but your data is level 8. But your security can be breached on browser. A security threat can happen on the gateway. A security threat can happen on the firewall. A security threat can happen on the load balancer. A security threat can also hack into your core application subnet. So you should know that this kind of an arc, so there is no single browser or just UI. You can understand that a hacker can enter in all the layers. So this is a Azure architecture of a cloud application. This is an AWS architecture of the same application. You can put an application in one of the clouds. Here the same way it is being modeled differently. You might have a EC2 computing instance. You might have a storage space called S3. You might also have a cloud watch. All the components are different here based on the Azure architecture. So these are two predominant architectures of the world. Your Amazon, your Google, your Walmart, all of them follow this kind of an architecture. Now, what happens during a chaos is, for example, if some guy hacks into the system and makes 10,000 users log in same time by AI, you will be finding the system going with extreme stress testing and load testing. Can I have the system have 10,000 concurrent users? Suddenly number of parallel users are high. Will the system break or will the system handle this load? If the system is handling the load, it should understand, is it 10,000 different people from different geographies logging in, or somebody is creating a malware and creating a bug, and this is not a human who is logging in. So you should know to evaluate this spike and soak testing and see what is the master data and transaction data impact. So in order to do this, what kind of mindset we need? Just like a Hollywood movie, the developer, the tester, the infrastructure engineer, all of them need to come together. They need to bring down some of the instances of an app. And if there are multiple instances, bring all the microservices one by one, bring it down and see what happens. Now you have to test it for load, you have to test it for security, you have to test it for availability, you have to test it for disaster recovery and user experience. This is the overall threat modeling that you have to do. If you are able to do this kind of a testing, then you are a new age developer or a tester. If you are just going to test only application level, DB level, old style, then you are not a developer at a latest knowledge. So definitely people need to understand what does it mean for security testing. These are all some of the major topics. It is impossible to explain all these topics in one session. These are pointers. You can take this and Google it, and there are separate courses for every bullet line. But just giving a small example, for example, if there is a cross-site scripting, if you are downloading some unwanted site and it puts a cross-site scripting on your mobile, when you are doing other application, this script is running in the background. So that's an example of cross-site scripting. So that can hack the data from what you enter on the browser, or it can do some computation. You should be able to find out whether there is a cross-site scripting or not. Another example is penetration testing. Another example is web application testing. These are all some of the terminologies. You can read it when you have your free time. So at the end of it, what is that we are trying to say? Using artificial intelligence, you need to create a model, you need to use the tools, you need to build a mindset by which you are able to understand what are all the ways things could go wrong. You need to be curious, you need to have a very different kind of a mindset, a changed mindset, and you are also knowing a number of tools, and you should be knowing what are all the ways we are using the application. Here I have put a link for some of the best tools in the world. So to sum it up, I would like to conclude saying that we are moving from a cloud maybe to cloud first to a cloud only world. So which means in future there will not be any servers. We will always have all applications on the cloud. So in that situation, we will have the maximum amount of threats of security things, and that would be the way forward. So this is my coordinate. I have put my LinkedIn coordinates here. You can connect with me for more details. And this is a high level session that gives an overall view about what is threat modeling and how does it affect the overall applications on the cloud. Hope you found some information useful for you. And right now I'll give it back to the organizers. And if there are any questions, you can ask me.
Good evening, Krishna.
Good evening. Go ahead.
Okay.
So
any
moderators,
queries?
please unmute the participants. If there are any questions, we can take it up. Otherwise, we can close the session.
Good evening, sir.
Yeah.
My name is Mallesh Rao, sir.
Yeah.
Sir, I have one doubt regarding to the PhD. One object I selected to threat detection, sir. Which tool is the best and how to do? I don't know, sir. Please give any suggestion, sir.
Okay.
Because I'm going to select as to the generative artificial intelligence cyber security, sir. But I don't know how will I can reach that target. Please give any help, sir.
So you can use this tool, Microsoft Threat Modeling Tool, TMT. This is one tool which is very good.
Microsoft TMT.
Threat Modeling Tool.
Okay, sir.
I do not know about your PhD topic, but this is in general a world-class tool. Otherwise, you can check the other tools given here. These are all from Gartner, the top tools of the world. So which one comes for trial usage, which one is license paid, and that you can decide. But amongst these 6, you can choose one.
Okay, sir. Thank you, sir.
Maybe I didn't share it and show you. So this is the screen. So amongst these 6 tools that you see on the screen, you can choose one. Okay?
Okay, sir. Okay.
Thank you.
Any queries? Please put it in the chat box.
Excuse me, Professor. Hello.
Yeah, you're audible. Please go ahead.
Sir, can you suggest the simple tool for the undergraduate student?
So these are very simple tools only. You can choose one of these 6 tools.
Like cyber security, if I am taking one subject, introduction to cyber security.
Okay, so introduction to cyber security, as I said, the topic is very, very vast. You have to narrow it down. For example, you have to narrow it from cyber security means you have to see if there is a way to capture incidents, if there is a way to, so let me go to that slide.
జాగ్రత్త సింబల్ పెట్టు దాని వరకు వండుకోమా నువ్వు కోడిగుడ్డు తిను చెప్పు కోడిగుడ్లు ఇచ్చేసి తీసుకో కోడిగుడ్లు నీ ఇష్టం వచ్చినట్టు చేసుకో నీ వర్క్ చేసుకో నరసింహులు మేము వెళ్ళిపోతాం.
So if you are choosing one of this, for example, I choose a threat model for my UG and there I choose a methodology. In that methodology, in one of this I choose, maybe tampering, maybe spoofing, maybe elevation of privilege. Now for this, you can go to this particular site, step-by-step guide for modeling your threat model and do a project. Don't try to do a project which has everything. Choose one methodology and one step in that methodology and do that as a project.
The methodology means the way of carrying out the work.
Correct. So for example, if you will go to Amazon or Microsoft and say, what are your security teams? They'll say one team is only doing monitoring. They are working with monitoring tools. Their job is to just monitor what is happening. Suddenly, if there are 50,000 logins to the application, then it is something wrong. How can 50,000 people suddenly log in? So they are monitoring. The moment they do some anomaly detection, they will pick that up and flag it saying that this is wrong. For example, if I am using my office laptop, if I take a USB and insert it, immediately there is a monitoring team somewhere in US which will say, this employee, this laptop, there is a device being attached. It is a security risk. Immediately my manager will get a workflow mail. So this is monitoring. Now let's say there is a attacker who has entered the system and the monitoring team has already found it. But by that time, the attacker has already retrieved the confidential information. Or let's say the bank accounts of 100 people have washed out all the money. Now, if you look at it, you have to find out which are all the users affected, how to do something like a mitigation step, how to run a program to give back the money. That is not monitoring, that is actually mitigation. That's a separate team that will be doing. There is a team which is only testing mobile application. In a screen of a mobile, is there any cross-site scripting? So there is so mobile security testing is a separate topic. Monitoring is a separate topic. Repudiation is a separate topic. Spoofing is a separate topic. Like that, there are multiple topics. So don't say I am doing a project on security. Say that I am doing a project of this topic of security.
Thank you, Professor.
Hello.
Yes,
Hi,
madam.
Sasikala. I chose the project PhD. I'm a PhD scholar. I chose the project as malware analysis, sir. I have a doubt in how can I practice in my system, sir? Because how to download the malware? If I download it means maybe my system spoil. Then how can I practice, sir? Can you please help me?
So you want to install a malware? Huh?
No, sir. I don't know how can I practice because I am doing project in malware analysis. I don't know how can I practice whether any data set or if I download the data set means it may be spoil my system. Then where I have to start, I don't know, sir.
Okay.
Mm.
I'm just imaginarily telling this. You can fine tune this later. Let's say, what is malware? There is some software that is installed on my laptop or my mobile without my knowledge. That is a malware. Without my knowledge, maybe I clicked on a wrong hyperlink or I downloaded an app. It installed my malware in my mobile or a laptop. Now, after that, I have to detect that malware and also detect what it has done as a damage to me. This is about security for a malware, this thing. So what you can do is you write a simple application in Python or .NET or Java or something by which that application creates username password. Okay. Just some random username passwords. It will keep on creating. Now you don't need to download a malware. You create a program, you yourself run that program and make that program run in background and put it into your cloud application or your server or your laptop, whatever may be. Within a matter of minutes, it will start creating thousands and 10,000s of users. So you will reach the upper limit of your login. So now you have to devise a security application that is able to say there is an anomaly. The application is overloaded with users who are concurrently logging in. There is this particular program that is creating users. It should detect. This will be a project. It's totally imaginary. I'm just telling it on the fly, but this is exactly what happens.
Okay, sir. Thank you very much.
I have posted one query in chat box. Please, can you answer it? Do you have any idea for prevention mechanism in AI? Attack prevention mechanism.
Attack prevention mechanism will be many, no? It will not be one or two. So if your attack is on the database, how do you prevent that? If the attack is on the UI layer, how do you prevent that? If the attack is on the cloud resources, how do you prevent that? So mitigation steps at each layer is a very big topic. So you have to narrow it down. For example, if the attack is on databases, so the easiest way to prevent database misuse would be clearly have classification of data. What role, what access. For example, if I have 50 tables in my application, I can say this role, this user, these tables, not only the table, at a field level I can define. For example, if a table has 50 fields, the manager can see only the employee can see the first 5 fields. The manager can see all the fields. So this kind of data classification, data access, role definition and authorization could be a mitigation step for database intrusion. So you will have APIs or you will have methods that call the database. It will check who is accessing it. Based on the user profiling only, data is given back. Everybody cannot see everything. Here the other thing is some people can see the data in masked format. For example, your Aadhaar. If I am retrieving the data, I will retrieve the Aadhaar, but I will show it in star star star. So this will be all masking, then authorizations, profiling, data classification is all the mitigation step for database security. Like this, there are other security mitigation at each layer for an API layer or maybe your gateway layer, network layer, firewall layer. There are mitigation. If somebody attacks the firewall, how do you mitigate? This would be something you will have to Google per topic. I have just given example from database side.
Okay, thank you. Any other queries?
So when I say threat modeling, it is about, okay, I have an application, I have 50 tables in it. Now in this table, these are the assets. These assets should be viewed for only these people. Like this, you are doing this actually in paper and pen in terms of diagram. So that is the threat model. Based on that model, what you do as mitigation is actually small coding, but the modeling is the whole topic that you need to see. For that only, I have given you the templates and all of that. I am not able to see an attach file button. How do I share the slides to you? I just mail it to Amuda, or should I, is there any other way I can share it to you? Okay. So at this juncture, I would like to tell something that me and Amuda are classmates in BE, and we share a good 25, 30 years of friendship, and I'm very happy that she invited me to this event. And I visited Wales Tech last year or this year sometime back for a different session. I'm so happy that the engagement is going on, and very, very happy and thankful for this opportunity. So at this juncture, I would like to share this with the broader audience, and my heartfelt thanks to Dr. Amuda.
Sir, regarding data sets, is it any idea, sir?
Regarding?
Data sets, cyber security data sets.
Yes, whatever I told now is actually part of data sets. So what is your schema? What are your tables? What is your data set? You classify them for cyber security. So whatever I spoke about database is all about data set security only. And it is done differently in different technology. How you do in SAP HANA technology, how you do in SQL, it's all different. So it's technology dependent, each database and what type of database, because you have now, there are different structured database and unstructured database. The way you do data set modeling for Oracle SQL is different. Whereas if you will look at a MongoDB, Cassandra DB, Sybase, these are all different kinds of DB. The data set modeling differs from technology to technology as well.
Sir, Amuda madam sir. Conduct பண்ணது யாருன்னு தெரியல. எங்க அவங்க 33 பிளாக்ல எங்க உட்கார்றாங்க? வாங்க சார். போட்டோ எடுத்தீங்க. போட்டோ இருக்கா?
கோவிந்தராஜன் சார்.
என்ன சார் அது அதான் சார் அப்ப அந்த போட்டோ
participants are requested to switch your system, switch on your camera and take the photo. One more question in chat box. Machine learning techniques for reliable and secure communication in IoT devices.
That's a difficult one. It is covering IoT, machine learning, and security. That's a very difficult one. I don't have an answer right away.
Today, Shankaram sir is also joined in this session, and Ramadana ma'am is also joined here. Sir is putting a message in chat box.
Thank you, sir. I'm so happy. Shankaram sir was my professor, and very happy to see you after 30 years. I don't see his face somewhere because the screen has more than 50 faces. I really don't know where are you, sir, but definitely we can catch up later. Thank you so much for joining this session, sir. Okay, 274 people who have joined this call. It's an amazing number. I'm really thankful. I'm sure many of you are from different colleges, different departments, and I'm very happy that you are listening to me. And thanks for all it. I'm not an expert. I'm just a beginner in many topics. Thank you so much. If there are some mistakes on my presentation, do let me know. But I'm very, very happy that you all participated.
Please kindly share the feedback link.
Thank you, sir. Thank you so much.
Thank you all. Have a nice day.
1 second, Krishna. Good evening to one and all present here. It's my great privilege to express my heartfelt gratitude to each and every one of you for taking the time to be with us. And I would like to express my sincere, heartfelt thanks to Krishna Kumar Mahalingam, Principal Software Engineer Manager, for giving a nice presentation and insightful session for the participants on artificial intelligence and cyber threat intelligence. And this FDP is mainly useful for all the participants for enhance their students' knowledge. I thank once again for giving a good lecture and accepting my sincere invitation, because so many schedule he is having. At the same time, he is spending for time with us. That is a great session. So thank you, Krishna. Thank you so much.
Thank you. Thank you so much.
So in the next session,
go ahead.
The next session will start at 7:30.
Okay. Okay. Thank you all. I'm signing out now. Good night.
Thank you. Participants, please fill the feedback form and then join the next session. The next session today we have the AI model creation for industry related projects. So we expect and also use our knowledge and use to get the knowledge from the expert and share to your students. I think it is more beneficial for you. So everyone can join at 7:30.